A solution is 0.085 molarity in Pb2+ and 0.025 molarity in Ag+. Selective precipitation is achieved using NaCl. What minimum concentration do you need to begin precipitation, and which ion precipitates first? What is the concentration of each ion left in solution once the second ion begins? So first we're going to find which ion will begin to precipitate first. So up here I wrote that the formation is going to be Pb2+ plus Ag+, and that you're going to be adding NaCl. So Pb is a positive ion, and so is Ag+. So they're both going to pair with the negative Cl ion. So I already wrote the KSPs, and you'll be given these, but here is Pb and Cl2. Remember, this is positive, this is negative, and that's why they're paired. And then Ag and Cl. This is 2 because this one has 2 positive ions, so this one needs to even out. So the KSP for this one is here, and the KSP for this one is here. So to figure out which one is going to precipitate first, we need to first know how does it precipitate. So whenever Q is equal to the KSP, that's when it'll begin to precipitate. And then whenever Q is greater than KSP, it is definitely precipitating. But we're just going to pay attention to when it equals KSP. So we already know the KSP's up here, so we're just going to write both of these and figure out the Q. So we'll start with PbCl2. So PbCl2's KSP is 1.17 times 10 to the negative fifth, and we're going to equal it to the equation it has for Q. So to set up the Q equation, it's simple. If it has a number here, then that's going to become an exponent, and if it has no number here, then you can consider it 1. So for this one, it's going to be Pb, which we already have the molarity for Pb is 0.085. And then here, since we're trying to figure out the molarity of Cl, we're just going to put x, and then we're going to square it because it has a 2 here. And then we're going to do the same thing for AgCl. So we know the KSP is 1.77 times 10 to the negative 10. We're going to equal it and then write out the equation. We already know that Ag is 0.025, and we're just going to put x for Cl since we don't know what that is yet. Okay, so now that we're at this point, we're going to solve for x. So when we solve for this one, you just do this divided by this, and then we're going to square root it to get rid of this square here. So I got that x equals 0.0117. And then we're going to do the same for here. We're just going to divide this by this. So here I got that x equals 0.00. Well, this number is actually very small, so we're just going to write it to the 10th to the negative power. So you're going to get 7 times 10 to the negative 9th. So these x's, remember, represent the molarity of Cl. So this one here has a smaller value for x. So this one is going to be used up first, and it's going to begin to precipitate because it reaches this point quicker. So now we're going to figure out how much is going to be made once the second ion begins to precipitate. So it's pretty easy for this value, since we know that once it starts precipitating, it's going to reach this value. And we just figured out that when we reach this value, we're going to have this number. Like, that's what we just figured out, because we solved for this value, which is the point of precipitation. So now all we need to know is how much will this be at. So by this point, the Q is going to be greater than the KSP, so that's what we're trying to figure out. But like I said, like, don't worry about that. We're not gonna switch this in the middle up. But what you're going to do is you're going to write out the same KSP, because you're still dealing with AgCl. So you're going to write the same KSP, and then here, instead of having this value, since this is the value of when it's going to precipitate, you're going to just write x, because we don't know what that is yet. And then for this value, you're going to plug in this value, because this is when this will precipitate. Because, like I said, this is the molarity of the Cl, and we know this is the molarity of the Cl when this second ion starts to precipitate. So when we calculate this, we get that our Ag is going to be at a value of 1.5 times 10 to the negative 8. So this is the value that AgCl will be at once our second ion begins to precipitate.